Hello friend, as we have discussed that in the next topic we are going to be start about the length of the belt. So here I am coming with the length of the belt. If you are going for this diagram, in the diagram we have the two pulley. This is your smallest pulley which is known as driver, this is your biggest pulley which is known as driven. If I am going to give the dimension, it's a small d, it should be your capital D. Now dear, the belt is in the contact with this pulley. If you are seeing the contact, this is a portion where the belt is in the contact and then after is going to be leave that pulley. So my dear friend, this contact, this angle is known as wrap angle. Alpha S is your wrap angle for the smaller pulley. This is your alpha S. So if someone asks about the what is the alpha S value, here all alpha S should be equal to, the line is a 180, and if you see this angle is your beta, we know the geometrical configuration, this should be also your beta, this should be also your beta. So what is this angle? Alpha S is your pi minus 2 beta. Now we have given the C. C is the center distance between the two pulley, driver and driven pulley. Now alpha V, someone asks about alpha B dear, again the wrap angle, this is your wrap angle where the contact between the belt and the pulley is taken place. This is your 180 with the geometry, this is your beta, this is your beta, means 180 plus beta, beta means pi plus 2 beta. This should be your alpha V wrap angle for the bigger pulley. D, as I told you, diameter of the bigger pulley, small d is the diameter of the smaller pulley, and C is the center distance. The diameter are in mm and the angle should be in a degree. Now dear, what is the length of the belt? Right now we are talking about the open belt. Open belt is that belt in which the belt is leaving the top of one pulley and go to the top of another pulley. But in the cross belt, the belt is leaving the top of one pulley and go to the bottom of the another pulley. So right now we are moving for the open belt. I mentioned here it's an open belt drive. Now dear, for that, what is the length of belt? Whatever the periphery is encountered with this belt, that will give you the length of the belt. I have labeled it ABC is that contact where the wrap angle is taken. C and D is somewhere is your that area which is not in contact with the any sort of pulley. D, E, F is again the arc which is again come under the wrap angle contacting the pulley, and the F and A is again that portion which is not in a contact with it. Whatever I have told you, I have mentioned here in the case of length of the belt. In the length of the belt, it is the sum of the arc ABC. If you go for there, length CD, I have already mentioned, then arc DEF and length FA. Now dear, if you go with the geometrical configuration, if I am making a one line which should be a parallel to this line, it is going to be an intersect this diameter at the point G. Now if I segment this portion, it's something like this. This should be your O, this should be your O dash, and this should be your G. My dear friend, it's making an angle beta. This is yours, we can say base, this is your perpendicular, this is your hypotenuse. Now dear, if someone asks about sine beta, as you know, sine beta is your perpendicular upon hypotenuse, P by H. So what is the P here? This is your P. Now we have go for this P, this is your P, and this sort is your H which is reflected it here. Sine beta is your P portion, and if you go with the diagram, the whole is your D by 2. D by 2. And this portion, this diameter, because we know this is a parallel to this, if this is your small d by 2, this should be also your small d by 2, this should be yours d by 2, and whatever this distance, this is your h is equal to c and p is your d by 2 minus d by 2. So by mean of that, d by 2 my small d by 2 by c means d minus d by 2c. We termed this as equation number 1. Remember one thing, the angle is very small, and that's the reason very soon we are going to consider this also as a beta, which is your d minus d upon 2c. Now what is a theta? Theta is the ratio of arc upon radius. If someone asks about the arc ABC, means the arc ABC should be equal to the angle of that. For the small it's alpha s, and the radius means d by 2. So alpha s into d by 2, alpha b into d by 2. This is for the arc ABC and arc. We can say DEF. Now what is the length CD and length FA? As this is a length at the free zone where no any contact should be there. So the length CD, or we can say length AF, both are the analogous similar, which should be equal to the C of cos beta. This is your C, and if you go for the component cos theta, we are going with the base. This is a base portion. So this is your C cos beta. I have mentioned somewhere C cos beta. Now we are going to place all the respective value in the above. But before that, remember one thing, we want cos beta, cos beta. Cos beta will become by the mean of the formula 1 minus 2 sin square beta by 2. So sin beta is your beta d minus d by 2c. Putting the value here, we have got it. Sin length CD or length F equal to C. This is yours C, and cos beta is a 1 minus d b c square whole square. Now we have to put all the desired value at the length of the belt. First, that is your arc ABC. For arc ABC, d by 2 into alpha s. We know alpha s. What is alpha s? Alpha s is your pi minus 2 beta, as I told you in the smaller. Then C 1 minus d ka whole square upon 8c square. What is that? They are all, that is your C cos beta, which we have gone for. That is that length which is not come in the contact with the belt. Then after we have the bigger belt, where we have d by 2 alpha beta. Alpha beta is the wrap angle for the bigger, and that time the pulley diameter is a capital D. And again we have the C cos beta. So here on the simplification, I am going to take d by 2 as a common, d by 2 and d by 2. So d by 2 upon d by 2, we have here d plus small d plus 2c minus d minus d whole square upon 4c plus beta d minus d. This is we got on the simplification. But now dear, what is a beta? We have to be known about the beta. Sin beta is equal to beta, which should be your d minus d ka whole square upon 2c. Putting the value here, d minus d and d minus d going to become d minus d whole square upon 2c. So we have here pi by 2 d plus 2c minus d ka whole square upon 4c plus d minus d ka whole square upon 2c. We are going with the simplification here. The LCM will going to be take place, and it will give you the resultant desired effect, that is your d minus d ka whole square upon 4c. And on the simplification, we have here length is your pi by 2 capital D plus small d plus 2c plus d minus d ka whole square upon 4c. This should be your length of the belt in the case of open belt drive. Now the question is come, what about the cross belt drive? My dear friends, small change we will encounter with the cross belt drive. What is that? See the difference. The top of the belt is going to the bottom of the pulley, and then after the top of the belt is coming to the bottom of the pulley. At this case, what we have feel here, the alpha s is pi minus 2 beta, but here it's going to leave here somewhere, leave here. So this is your alpha s and this is your alpha b. So what about the alpha s? Alpha s is your, this is your 180, the contact area, whole contact area. This is your 180 plus beta and beta. So it will become, what is that? Pi plus 2 beta, and here alpha b is again 180 beta and beta, pi plus 2 beta. One more change we are going to be encounter, that we are going to be consider the one line parallel to this line, and then after we are make it. So this time we got a one triangle something like this. In the previously we had did here this portion d by 2 minus d by 2, but here this is your d by 2 and this is your small d by 2, means somewhere sin beta should be yours capital D by 2 plus d by 2 divided by, my dear friend, c. So the difference is your sin beta should be equal to beta equal to d plus d by 2c. This sort of changes you are going to feel in the case of cross belt drive. Remaining all the portions should be same. Thank you very much for watching. Thank you.